COVID-19. Today we're going to have a keynote session by Chiara Magliaro on image processing for detecting COVID-19. She will explain step by step how to use algorithm for identifying the effects of the virus. Then later in the afternoon we will have a webinar presenting some activities in Kenya for fighting COVID-19. And I will remember you that tomorrow we will have at 4 p.m. East African time the awarding ceremony of the UBORA design competition. So you can have also additional contribution to your ideas. And finally, on Friday, we will have space and room for presenting your project. So now I'll invite Chiara to give her talk, and I'll mute myself.
Hi all, good morning everyone, and welcome to my house. Today I'm going to talk and discuss with you about the role of image processing in facing COVID-19. Let me first introduce myself. I am Chiara. As Carmelo told you, I got a PhD in automation, robotics and bioengineering here at the University of Pisa, and now I'm a postdoc researcher here in Pisa. My work mainly focuses on image processing algorithms for studying brain architecture at the microscale. This may seem to be very far from coronavirus, but actually it is not. In fact, all the methods, the tools, the algorithms, the practices for analyzing an image or groups of images can be the same, even if the applications are very, very different. Let's go through the discussion. COVID-19 disease, as you all know, is caused by the SARS-CoV-2 virus, and it is disrupting the world and spreading worldwide. Here you can see some data from the Johns Hopkins Institute from 2 weeks ago. Unfortunately, we know very little about the best treatments for facing COVID-19, but we know very little also about the best way to get diagnosis. In this light, we need to join forces for finding a fast and accurate method for diagnosis COVID-19. What does the current diagnostic pathway for COVID-19 look like? The protocol is that one. If there is a suspicion of COVID-19, for example, if a patient, an individual has been in suspected territories or in touch with a person already diagnosed with COVID-19, the common way to diagnose it is to run a laboratory test. Usually, this test is an RT-PCR test. How does it work? Briefly, a specimen of the patient is collected through a nasopharyngeal or a throat swab. Then a chemical process is activated for extracting RNA. Then a specific enzyme is used to turn the RNA to DNA, which is then multiplied to obtain a lot of short DNA filaments called primers. Using fluorescent dyes, we can detect viral DNA that allow the care providers to say that a patient tests positive or negative to coronavirus. This test is believed to be high specific, but we have a huge problem of sensitivity. In fact, the sensitivity seems to vary greatly depending on country. You have to think about that in short time, all the countries struggled to develop a test based on the same principle, so RT-PCR, but they have no time to standardize it and to standardize the procedures. This leads to a sensitivity ranging from 16–17% to 95–97%. And the sensitivity of the test also depends greatly on the time since exposure to coronavirus. Here you can see a graph of the percentage of false negatives over the time since exposure to the virus. But why we are so interested about false negatives? In particular, for COVID, in the COVID era, the false negatives are a real clinical and social problem because a false negative individual feels himself or herself safe, and he or she is uncontrolled in getting in touch with other people spreading the virus. For the lab test, the protocol usually we need several negative tests in a single case to be confident about excluding the disease. This is for sure not fast and not cheap at all. We need to find an alternative. Medical imaging-based methods seems to be an alternative to RT-PCR, and for sure we will discuss later about how much better or cheaper they are with respect to RT-PCR. But among all the imaging techniques, since COVID-19 attacks the epithelial cells in the respiratory tract, radiological imaging is the most talked about contenders, is the best candidate for fast and accurate diagnosis for COVID-19. In fact, this kind of imaging was already of real help at the beginning of the pandemic in the first stages, when the lab tests were not ready to be used, and they are still widely used in countries where lab tests lack, for example in Turkey. Radiological imaging is usually referred to X-ray imaging or CT scan imaging. Of course, the two techniques are different, even if they leverage on the same source of energy. X-ray, here you have an image, refers to the widely available diagnostic imaging test worldwide. Image formation is based on the fact that the radiation is able to pass through our bodies more or less depending on tissue density. The less dense tissues are hard to see and they appear gray. On the other hand, the CT scan generates, of course, a high quality and detailed image of the body. You can think about it as a more powerful and sophisticated X-ray that takes 360-degree image of your body. What we need to do, we need to detect COVID-19 accurately, but we have also to distinguish COVID-19 from any other lung diseases. And if possible, we want to have a tool for follow disease progression. Unfortunately, interpreting radiological imaging is a job for medical doctors. It is very hard to interpret radiological imaging. It is a nice skilled job. The medical doctor do it manually and after many years of training. I want to give you an essay of the challenge. So let's see some images and let's imagine to dress the clothes of a radiologist. As I told you before, both X-ray and CT scan are used for detecting pulmonary disease, for example, for detecting tumors or pneumonia. Here, you can see the lungs of an healthy man, how the lungs of an healthy man look like in a slice of, from a CT scan. As you can see, lungs are characterized by a uniform shade of gray, and you can see clearly the bronchovasculature, all these arborization you can see here. Now, let's compare this picture to these other two, one from COVID-19 patient, the other one from a pneumonia patient. Well, here you can see ground grass opacity and crazy paving appearance. These are techniques, more technical terms to refer to non-uniform lung shade of gray. And you can see in both the picture bronchovasculature thickening. So, how can assess which one is from a COVID-19 patient and which one is from a pneumonia patient? It's quite hard, and that's the reason why interpreting these images is a job for medical doctors. But we are facing an epidemic, and during an epidemic, it is unthinkable to spend the efforts of doctors just for interpreting X-ray and CT scan images. Medical doctors are busy, need to be busy in other activities. It will be too expensive, too time consuming. We, as an engineer, can help overcome this issue, welcoming on board artificial intelligence. It is already been shown that artificial intelligence is a route for faster and more accurate diagnosis done through imaging. In particular, deep learning is widely used. Deep learning, as you may know, is a branch of machine learning that actually wants to teach computers to do what came naturally to humans, so learn from experience. In literature, there are different works that demonstrated that deep learning is compliant with the relevant standards. It was demonstrated through certification, of course, obtained by means of clinical trials. And there are, in some hospitals and some clinics, several tools already available, able to identify specific disease. I want to give you some example. Quantix is a computer-aided diagnosis software assisting in the assessment and characterization of breast abnormalities acquired with MRI. Here you can see a breast lesion. It is classified as a class 2 medical device, and it is able to identify breast lesions thanks to a convolutional neural network. So actually is a deep learning, basically is a deep learning method. IDXDR analyze images of the eye for signs of diabetic retinopathy. And it is a very good example because for its high accuracy, it can be used also by healthcare providers who aren't normally involved in eye care. The last one is Profound AE software that is able to analyze mammograms for lesions suspicious of cancer. During the analysis, the software is able to crop the image like that and classify these patches in positive or negative masses. This overview is just to inform you that artificial intelligence is a real thing. It is already and successfully used in clinics. And of course, the scientific community is aware of the potentiality of this methodology and of the possibility of applying this methodology for COVID-19 diagnosis. Different work have been already published demonstrating the feasibility of deep learning to screen coronavirus disease. Here I list some of them, but they are a lot. Today, I'm not going to describe what they did in these publications. I'd rather like to push all of you to use the datasets available online and the methods we are discussing for learning about deep learning. In fact, there are different sources available for learning, leveraging on the data sets that COVID-19 is giving to us. As an example, PI Image Research is a very good blog for a very skilled guy that already tried to implement a neural network for COVID detection using one of the most famous library in the field, TensorFlow by Google. And he also used some GitHub repositories with X-ray images from both healthy people and COVID patients. Here you have the links. Of course, we have a lot of images from healthy people, but not too much for COVID patients. Okay, we can discuss later. We will discuss later about this issue. Of course, it is not mandatory to use TensorFlow or Python. For example, I have never coded in Python. I'm not good in Python. So I tried to implement the same neural network with MATLAB, using the same image the guy from PI Image Research uses. Just use the language with which you are more confident. Just be sure that the language you are choosing allow an easy implementation if you are not that nerd to implement a library. For example, with MATLAB, you just need 10 lines of codes. So it's very, very easy to implement a deep learning network. Regardless of the code language you want to use, the workflow you need to follow when dealing with deep learning for image analysis is always the same. Deep learning uses a computational method to learn information directly from data without relying on a model or a predetermined equation or a model, as a model. So the first step for our workflow is the four steps are: identify a training dataset. We already told about it. The dataset is needed to teach the network to do its job. Then we need to define the network architecture. We need to train the network, and finally use the network on a new dataset for assessing the ability to predict the labels on this new data. For labels, I mean COVID, pneumonia, cancer, healthy people, okay? Let's start with the first step. For the training datasets, I used a posterior-anterior view of the lung scanned with X-ray. This is the most common radiological investigation in the emergency department. Most of the hospitals have one of these. That's the reason why I won't use a CT scan, because a CT scan is located only in big health centers. Thanks to X-ray, we can see lung, the dark one. We can see bony thoracic cavity. We can see the mediastinum, the shape of the heart, and great vessels. X-ray is, of course, cheaper than CT scan and works with a less amount of radiation. So it's safer, both from the patients and the healthcare providers. So let's choose X-ray images. For training my network, I used 25 images from COVID-19 patients and 25 images from healthy individuals. A dataset with just 50 images is very, very poor. The accuracy of the network won't be good. You cannot use this training network in clinics, and nobody is going to certify this tool. We are just implementing an example to learn. just for educational purposes. And of course, as a primary step to do better things. At this point, we try to define network architecture. As you all know, I think, deep learning network is a layered network by definition, okay? I don't want to just give you the code. I want to try to implement by hand our layered network. Let's see what happens. Let's imagine to have an X-ray scan able to acquire images just with 4 pixels. Okay, 1, 2, 3, 4. This pixel can be just in a grayscale, where -1 is black, +1 is white, and we have 0 for gray in the middle of the two. Let's also imagine that we want to implement an algorithm that automatically is able to detect these 4 features from an image. The features are a solid image, all black, all white, with quite the same grayscale of the pixel. Or we want to detect image with quite the same shades of gray arranged vertically, horizontally, or diagonally. Okay, and we can imagine that these features are somehow linked to normal lungs, lungs with pneumonia, lungs with cancer, lungs with COVID, for example. Okay, just imagine. Even if we have just 4 pixels, it is very tricky because you can't do this with simple rules about the brightness or the darkness of the pixels. You can't do this with simple image processing toolboxes. We need the help of neural networks. So let's start. We need to take our 4 pixels and list them, break them in 4 input nodes. At each node, we assign a number specific of the grayscale, so the darkness of the brightness of the pixel itself. This is called the input array of our network. It is just a list of numbers that represents our image somehow. Usually, it is useful to think about each node as a neuron because it receives information as an input and is able to process this information somehow. For the input layer, we are quite lucky because the information is just the brightness of the pixel. To build a neural network, we need to create another neuron. Okay, that one, the green one. This neuron is able to add up all the values of the input neurons. The sum can be weighted somehow if the connection, the link you see here are weighted. The weight can be a number between -1 and +1. Okay. In this manner, the neuron the function of the neuron is just to perform the sum of all these products and squash the results to be sure that it falls between -1 and +1. The squashing is helpful for keeping the neural network stable, bounded, okay? Now, let's complicate a little bit the things. Instead to have just one of those neurons, assume you have a whole bunch of neurons, okay? I'm considering 4 neurons because it is made by hand, okay? So the things are easier. But you can have 400 neurons or 4 million neurons. It doesn't matter, okay? Regarding the connections, at the starting point, each neuron of the layer you are creating is linked to all the neurons of the previous layer. And they have some weights between -1 and +1. We will talk later about what happens to the connections during the learning. In this new layer, the neurons get more complex because they have to process information from a mixture of the information belonging to the input neurons, okay? They are dealing with a mixture of information belonging to different neurons. At that point, we can add new layers, or we can change the number of neurons from each layer. We can also change the neuron type. For example, here, the orange one for me are neurons that are able to put to 0 all the negative values and maintain the positive values as they are, okay? Finally, we can add an output layer. The output layer is supposed to represent the outputs we are interested in. So, solid image, vertical image, diagonal image, horizontal image. Remember that for us, the horizontal pattern is related to COVID-19, okay? This is the neural network. Why we are called it neural network? Because it perfectly mimics the layering of the brain cortex. Here you have a confocal imaging of a brain, of the brain cortex. But biological neurons are not just layered. They have another feature. They have the plasticity. The plasticity means that they are able to strengthen or weight the connections on the basis of the outputs. That's the reason why we learn from experience, okay, because of the plasticity. This is actually what we are going to do in the artificial neural network, going to the next step, the training of the network. So here we have our neural network. All the neurons are connected with all the previous layer. Now we need to train it. We need to start with the fully connected network, and usually the weights are randomly chosen. So the weights of each link is randomly chosen. At that point, we need to put an input that we know the answer to. We know the truth. We know that is a solid, vertical, diagonal, horizontal image. We run the network and we see what happens. And we calculate the error between what the network gives as a result and what we actually want as a from the network. Using a method, a well-known method called backpropagation, we adjust all those weights from the output back to the input layers, okay? We need to do it again and again and again with a lot of inputs. The error, as you will test that the error will slow down, and after different training sets, the network will do pretty close to the truth on most of the images. Of course, the bigger training data sets is, the more accurate is the results. That's the reason why I told you that 50 images are, it's a poor data set, okay? It's a poor training data set. I trained this network for you by hand, and that's the result. For the sake of clarity, we have just negative or positive connections. So we have just link that weight -1, the black lines, and the colored lines are just for +1. Now, we need to test the ability of the network to predict labels on the new data. So we need to understand if the network, this very easy, simple network, is able to understand which image is from which patient. Let's see. And let's take the image from the COVID-19 X-ray patient. Here we have the input neurons. The input neurons are with their values, so dark on the top, bright on the bottom. Let's move to the first layer. Okay, the first layer is that one. We have gray in the first two neurons, and we have black in the second ones, according to the sum up and squash processing of the neurons. This makes sense because the first ones are related to an image that have at least 1 pixel in the right place, but the second one, no 1 pixel are in the right place, okay, as you can see. Let's move, oh sorry, let's move on the second layer that works with the same rules of the previous one. Here you can see that the gray values just propagate as they are. The other ones change their value, that one, change their values according to the weights and in accordance with the image they are representing that I draw here, okay? Let's move again. Here, remember, the neurons are different. They are not just adds and squash. They work as a rectified linear neurons. So positive values remains are maintained as they are. The negative values are put to 0. These allow the grid spot to maintain their values. So 0 is 0. The ones changing their values are the last one, according to the negative connection you have here, okay? This leads to the final results in the output layer. The neuron representing solid, vertical, and diagonal image, so normal, tumor, or pneumonia X-ray images in our case, give a false as a result. The only image giving a true result is exactly the one representing the horizontal line. That is the COVID-19 feature. That's how the magic happens. It's not magic, it's just math. Of course, everything is going to be more difficult when we are dealing with the real images. And I want to disclaim that because the literature claims that clinical imaging is of course more sensitive, detecting cases that swab misses. And clinical imaging also gives real-time results, and it is also, of course, an advantage with, when you are you need to face an emergency like COVID-19 is. But of course, the methods have some cons because false negative are a real things. There are no techniques 100% accurate, and the scan is told to be not for the benefit of the person having the scan. That means that you are giving patient radiation, okay? And also to the care provider, of course. We need also to deal with scanner contamination. After each scan, you need to sanitize everything. For all these reasons, for example, for the American College of Radiology, clinical imaging and the related deep learning techniques for detecting COVID-19 cannot be used for its diagnosis, okay? But I wanted to talk about it because I want to push you, as I told you, to learn the mechanisms of deep learning. Okay, for sure, it is not meant to be reliable. Also the algorithm, the network I implemented in MATLAB, it cannot be high accurate as the other software I showed in the first slides. The network was not supervised by a trained medical doctor who can actually assess the goodness of the image classification performed by my algorithms. This is just to inspire you and open your eyes to how we as engineers can make the difference in the COVID era, step by step. And most importantly, I hope that I have convinced all of you that for boosting a timely and accurate detection in this strange scenario of emergence as COVID-19, it is really important to share data, share findings. I cannot implement my neural network if the data sets won't be available online. We need to find human supervisor for the network outcomes. We need to improve the network with the help of engineers and coders. And that's exactly the philosophy of UBORA platform and of this bootcamp. So let's go on. Thank you for listening and thank you for inviting me. Here you have my email. So if you want to send me an email to discuss and to try to implement something, just email me. Thank you.
Thank you, Chiara, for your talk. Any question from the student? Guys, questions and comments? David?
Yeah, Camilo.
Yes.
Thank you, Clara Magliaro, for the presentation. But this, my students have been doing the same, trying to come up with a way of detecting COVID-19 using the image. They're using the deep learning and the algorithm. But the only challenge you always get through and we're always being challenged is the process able to detect this COVID-19 at early stage? Having that you are using an image, like for pneumonia, you're getting that image. Yeah. For the early stage, is it possible?
I don't think so. You need to have a lot of images. You have to, it is just to make, on my slides, I just exemplified a lot. You need a lot of images for training your network. I lose you, I think.
My network has an issue?
I cannot hear.
Can't hear me.
In the meantime, I don't know if there was also Lucas.
Thank you for the good presentation.
Hi, Lucas.
Hi. So my question is the deep learning method maybe able to identify COVID-19 in patients who are symptomatic, those who don't know, who don't exhibit symptoms?
Mm-hmm. Actually, you can use X-ray also for detecting COVID from asymptomatic, but you have to think about a thing. Nobody's going to do X-ray if they have no symptoms. There are some studies with X-ray also from asymptomatic patients, but I don't know. I'm quite skeptic about that that point. I'm not going to do a CT scan or an X-ray if I'm good.
Okay, okay, thank you.
I think David lost the connection, but if he wants, he can just email me.
Oh, problem.
Okay, I'll leave it.
David?
Yeah, I'll email back as she's suggesting. Can she hear me?
We can hear you.
Okay, now.
My question partly you have answered my question partly from the Lucas question, but the question which we were asking is, using the algorithm, is it possible to detect COVID-19 at early stage?
Yes, you can use it. If you want to, I can share you a very good publication about it, because there are some guys that are able to follow the disease progression from the early stage up to the final stage, let's say. So you can use X-ray. It is always the same things. Nobody's going to do all these X-ray images in a very short time because of the radiations.
Okay, thank you.
Welcome.
Any other question? So if not, I want to thank Chiara again for a presentation. You have her email address, so you can write directly to her. I was wondering if she can share the presentation with the group.
I'm sending to you.
Okay, perfect. So the presentation will be in the same Google folder that you already have. There are 2 comments, Precious and a team, who congratulate you. So now I'm opening the breakout rooms for the World Day. I received a message from the next speaker who is not well. So